Well, thank you, George, and thank you for your invitation, your very generous invitation to participate with such an esteemed collection of colleagues, many of whom I've worked with, many of whom I'm meeting for the first time. I'm an astronomer. I work next door at IPAC, and I have been doing visualization for a lot. But for those who don't know me, I thought I would start with just a quick overview of my career trajectory, which easily started as a kid watching Star Trek with my dad, some of my earliest memories. But it was also deeply shaped by other influences like Isaac Asimov, Carl Sagan, but also astronomical artists. Rick Sternbach, who presented 2 days ago, was literally a direct inspiration to me. I actually had exhibited artwork in science fiction convention art shows, like alongside his work, and found this incredibly inspirational. And it's because of just this intersection of science and pop culture and visual effects from last talk, right? Just these things created in me this incredible inspiration and drive to want to know more about the universe, but to make cool pictures of it. So I sort of went through a parallel track on an astronomy track, ending up as a staff scientist at IPAC. In the meantime, doing airbrush acrylics, then later digital Photoshop and 3D graphics. But I had a unique opportunity to converge that into a single unified career that a colleague of mine dubbed an astrophysicist. And so for the last 20 years, I've been doing visuals to help tell science stories. And I've had the incredible privilege of working with so many incredible missions, space-based, ground-based, the original LIGO results, Event Horizon Telescope. So I was trying to encapsulate all of this into why do we do astronomical art for communications? And I'm going to do a lot of definitions up first. But the initial idea is there are many times the data itself can tell a beautiful story. And if so, we just run with that. But sometimes the data needs help for both engagement, but also clarity, because these speak incredible things to people who know how to read the language. But people who don't, we need art to illustrate that. And the central theme of this conference is inspire. And this is a key part that got me to take astronomy as a career, to move into what I do. But the other aspect of what I have to do is to inform. And it's these two in synergy that sort of define what I will sort of dub astroviz or astrovisualization. So pardon me a minute to visit some of my early work. Something I actually just rediscovered just this year, visiting my parents' old house and going through some old things I hadn't seen in a long time. And I stumbled across what is possibly the earliest Hertz original of a galaxy, circa 1979, I believe. And the first thing I noticed when I dug this old frame painting out was like, my God, that is terrible. How did I screw up everything about phenomenology, what a spiral galaxy is? And in particular, I was very horrified that the center of this galaxy was just this kind of mushy, undifferentiated center. And I'm like, what was wrong? I mean, through my modern lens. And I realized that at that point in time, my inspiration for the art came from photographic works, where we are taking telescopes, we are doing deep exposures to try to bring out the faint outer extents of galaxies. But due to the limits of photographic technology, we were also simultaneously overexposing the cores, hiding very real structure there. Now, today I have the benefit of high dynamic range data sets and having processed these to release images that we put out to inspire people. And I know just like the back of my hand that galaxies are incredibly dense in their center. They have strongly peaked distributions of stars. But that wasn't something I got as a kid because I didn't see it, which really drives home the point that visualizations can deeply affect our mental geography of the universe. And that is especially true in artwork, which can distill down, simplify to focus us on very specific ideas. So another thing I wanted to find is what is communications? It's a term we use a lot in my field, but it's roughly like a spectrum, where on one end you have formal education, which happens in classrooms, facilitated. In the middle, informal education, where people choose to go to a museum to receive educational experiences. And the other end is communications, and that's like news media and news outlets. And I think the primary differentiation of this and how graphics work is how captive your audience is. The kids in your classroom, they can't leave, and so they have to look at what you show. Museums, people have chosen to come there. They're a sort of a semi-captive audience, but when we're in news media, we are competing for attention, and we want you to click on our article instead of watching the trailer for the next Marvel movie. So we have to grab your attention. And we have to achieve multiple things with that artwork. The artwork is like the headline. It may be the only thing people see of a story if they move past. So you want to grab people's attention. You want to instill in them a basic concept, at least, that gives them foreknowledge so that then if they can lead them to the article, it will help frame their understanding of what they read, particularly for very complex ideas. So I initially started trying to build this talk around some abstract idea of like the data art continuum that somehow had like pure data plots on one side and pure abstract art just done to be evocative, but with no information content on the other. And I realized I was really conflating many things into one oversimplification. So I've sort of stretched that out a little bit to be maybe two different axes, a visual engagement axis along the bottom, somewhat reflective of artistic freedoms you have in expression, and a science content axis along the vertical. This is the inform. This is like how much can you actually learn of functional science knowledge by approaching it. And we can layer in a few basics, like maybe peer-reviewed scientific journals fall way up in this corner. Not a lot of artistic creative freedom to express, but a lot of information. On the other side, we can maybe put Guardians of the Galaxy, really visually exciting and engaging, and you're not going to learn much of anything about how the universe functions. We can maybe even put Plan 9 from Outer Space down at the axis because you're not too engaging and you're not learning anything from that either, except space zombies, I suppose, someday might be relevant. So we can have fun placing other pop culture things along this axis, these two sort of this anti-correlation that I was perceiving to exist where, Star Trek has a little more science, but is still more focused on the visual, the inspiration. Maybe a show like The Expanse, a little more science. Cosmos, definitely much higher on that axis. But what I really want to focus on in my work is trying to pull off of that anti-correlation and pull as much as you can into a territory that is both inspirational and informative at the same time. And that's an area I dub astroviz, and we have a sort of a community of practice around this. Now, how do you do this? Well, at IPAC, for the last 20 years, we've developed a technique that I'm now today going to officially dub the Astroviz Trinity. And this is a critical balance between three different voices that I mean literally as voices you want at the table, on a meeting, each advocating actively for these different concerns. Of course, science is where the story comes from, and the scientist will have a deep understanding of what that story is and what is true and false in it. A communications expert is the person who's going to help tell the story, and the artist is going to add the awe. So how does this functionally work? Well, the scientist will have a very detailed sense of what the narrative is, but it is going to be over the head of your key audience. And the role of the communicator is to come in and help decide what is the narrative that you can actually communicate to the audience that has been identified, right? And it's a simplification. It'll cause a little stress in the science, I imagine. And the artist can bring the insight as to which ideas here are intrinsically visual and what can be done to add appeal and engagement to that. But at all points, it has to happen as a dialogue, always back to the science, to make sure you don't simplify something to the point of being untrue or misleading. And so it's a constant process. And I love these conversations we have when everyone is on the same call and we're all pulling in these different directions. And if we get to a point where none of us is completely happy, then I think we've landed on the right spot, the sweet spot in the middle of the Trinity. So another way I have thought about this process that I go through in doing astronomical art is sort of abstractly thinking that there is a space of known facts in a given result, that it's been established in this result that you have to choose from. In addition, there's going to be many more things you know are absolutely ruled out by a particular result. These are the known falsehoods. In the space between it, many more possibilities, things that are neither directly supported nor overturned by the science. And as an artist, you can't just make a piece of art that could be this or that or the other. It's not like I can paint a Schrodinger's cat of multiple superpositions of states of an exoplanet that's many things all at once. No, you have to make a decision. So you have to draw a circle around some of this. And you'll pick a few of the science highlights you want represented in the art. you will pick a collection of possibilities that you will represent specifically, and you may even include some known falsehoods, particularly if those are actually in service to getting the communications to be successful. And one primary example is maybe exaggerating the relative scales of exoplanets in a piece of art if you want people to be able to see the things that you're trying to get them to understand. So yes, sometimes falsehood is a conscious, intentional part of this. So art is what you do to fill in all these gaps and have a complete piece that's a full experience. Now, if you've done the job well, I posit that the art is functionally equivalent to a hypothesis. And this is not my idea. It actually came from a colleague of mine, Bob Benjamin, and I'll talk about this later as we go through some examples. So the first example I want to talk about is the Milky Way. So we see the Milky Way everywhere in the sky, right? Why do we need to illustrate it? It's there. We totally see it. Well, to talk about this, let me go to a very different analogy. Let's say I drop you right down in the middle of Times Square in New York City, okay? And while you're standing there, I give you an iPad and a pencil and say, okay, map out Manhattan for me. How good of a job do you think you can do? I mean, you do have some sight lines that are going to go for a long ways. You can sort of see buildings. You can make some guesses, but you have things blocking your view, and you're right on the street. It's hard to judge actual scale. Well, it's the same problem we have sitting smack down in the flat plane of this big disk of Milky Way. And as we learned at Carnegie, it's only in the last 100 years we even figured out we weren't at the center of all of this mess, right? This isn't easy. We have big clouds of dust that block our view. It's hard to judge distances, so it's actually a bit of a mess. My first chance to take on this daunting task of illustrating the Milky Way was in 2005 for a Spitzer release with my colleague Bob Benjamin, who had a fascinating result where we were able to much more precisely nail down the size and the orientation of the bar that runs through the center of our Milky Way galaxy. Now, the fact that our galaxy is a barred galaxy is something that really was only becoming known when I was in grad school. And it was well established in radio observations, but it is not something that ever existed in the artwork I saw as a kid growing up. And it was conceptually something I had to get used to. And despite the fact that it has been very well established since, easily the early 1990s, it has taken a long time for this idea to propagate into the visual representations of our galaxy. In part because many artists, we have memories of how we've seen, and you try to repeat things that you're comfortable with. So this is a great thing, and we were happy that we did this. These were sort of the bullet points that were in this. But to our delight and horror, this image got everywhere. And it was being touted as the view of what NASA thinks our galaxy looks like. Now, I didn't actually work very hard on these arms because we weren't telling that story. We were telling the story of the bar. And I was literally getting contacted by scientists saying, hey, you should see my paper about the H1 map of this area or the CO map of that area. And you've left out my arm. And Bob and I were like, we got to fix this. By the way, you can even spend about $60 and get a print for your wall. Don't. This isn't a good one. So we actually did have an opportunity to revisit this in 2008. And you may have seen this image. This was both a Spitzer press release, and it was actually then set up as a workshop at the American Astronomical Society meeting where Bob contacted people who had been all working on galactic structure, but kind of off in their own silos in radio or infrared or maser work, and tried to bring them all together to compare notes. And in the process, he and I went through a collaborative process to try to consolidate and make our best guesses of how this all would lay into a single picture that would be our best map to date on the actual geography of our galaxy. Now, even this, I will say, has a lot more bullet points in it than the last one. We were a lot more secure. We were trying to put a lot more reality into this view, but there's a lot of guesswork in here too, because for various reasons, it is very hard to deduce anything systematically about what's going on in the far side of the galaxy. And that was going to be guesswork. And we actually debated, should we show really just the parts we know? But Bob and I both felt we needed a clear, consolidated image that if you want people to really understand and be engaged with it, you can't put a Pac-Man cutout and have them think that they're responding to the galaxy. So I felt he gave me a lot of free rein. I filled this in with art and symmetry. But it turns out multiple features that were in this extrapolated artwork have subsequently been discovered. In particular, this outer arm, Thomas Dame, who works with radio data, had mapped out and finally detected a hydrogen gas arm in the outer region. And when he went to overlay his data on that figure, because it was actually used in a lot of research papers as a reference point, he noticed that it followed exactly the art I had put on the graphic, even to the right ending point. And he contacted me because he was suddenly worried that he didn't have original research and I had access to some data set that he didn't know about, and that, like, oh my God, am I actually doing it original or do I need to be referencing someone? And I said, nope. That was just the power of symmetry and artistic discretion. But it was a hypothesis that was borne out. Art as hypothesis. It's very powerful, I think. So that is not as powerful, though, as watching an incredible presentation by an artist that you have incredibly deep respect for, who's done truly sublime works, and to see something that you've done to help explain science used as part of his explanation of the incredible installation he's working on in Rodin Crater. This is a moment, for everyone who was there yesterday, I will never forget this. So another case study. Again, no intimidation after following this lovely presentation on black holes. I'm going to talk about visualizing black holes from my own crude way of approaching this. Now, pop culture, as we've seen already, has many references to black holes. These are some of a few I pulled out, an old favorite, Space 1999 from 1974, Stargate SG-1. But as I was going through and finding what pop culture does with black holes, I found that they really fell into very specific categories. You got your bowling balls, you got your bathtub drains, and if you're J.J. Abrams, somehow a black hole becomes a flat, swirly thing with lots of lens flares and stuff coming out of it all the time. I think he really missed the point on black holes. But anyway, yes. But in fairness, that can't be too hard on pop culture, because really, astronomical illustration in the service of communications has followed much the same thing. I've done my fair share of bowling balls. The bathtub drains, easy to understand because, we commonly are showing these space-time diagrams that without maybe completely getting across the idea that these are three-dimensional analogies for a four-dimensional space-time into a distortion in which we can't perceive in 3 dimensions, but we can simplify it down to 2 dimensions. But you look at it and you think bathtub drain. So sure, we'll go with that. But we've known for over 100 years that black holes warp light. I mean, again, we know that just the deflection of a star's position in the sky, as we've learned, is how Einstein was fundamentally proven correct. So why don't we show this in visualization? I honestly think it comes down to 2 things in my experience. It's harder to do, and this has been my excuse on more than one occasion. But even more fundamentally, it's not what people expected to see. And expectation can have a very strong influence in what you create and how it is reviewed by your peers. I know this from personal experience because back in 2008, my colleague Tim Pyle made a short video called Spaceship Spitzer, where Michelle Fowler, who reps a lot of NASA discoveries these days, travels to a black hole. And I insisted that he do some representation of the gravitational distortion around this black hole. And he pushed back saying, that's confusing. People won't understand it. And I was very insistent. I bully people to get my way sometimes. And he did it, and I think he was actually happy with the final product. But to my knowledge, that was the first time we ever saw a spaceship flying around a black hole that had a gravitational distortion represented. But there was pushback because of the idea that people didn't see this. I had a 2010 press release where I did the distortion around a black hole with a kind of far-out accretion disk, and the pushback I got from the JPL communications team is, I don't get this. That's all weird and warpy, and it's going to confuse people. And I said, well, sometimes you need to confuse people because you want them to know something's happening. And again, I got pissy. I threw a tantrum, got my way, went out. But the pushback, because it defied expectation, was very significant. Then something miraculous happened. 2014, you have a director and an astrophysicist, a physicist, who actually talk, and someone who wanted to create something in pop culture that was astrophysically reasonably correct. In fact, so correct, multiple peer-reviewed scientific papers came out of the visualizations done for special effects. it was truly a remarkable moment and powerful in the film, but it had a ripple effect because now it changed the field on expectation. And if you get to the point that Star Trek will now show the proper gravitational distortions around a black hole, how can we do any less? It brings me to, so how do we do this? Well, I'll breeze through this quickly. I don't need to belabor it. But for many years, back in grad school, I created this idea of like a refractive lens that would basically get you kind of partway there. It would kind of bend light, never more than 90 degrees, but it was enough to get things like an Einstein ring effect. I used it to good effect, even sometimes with multiple black holes, but it got really futzy because you couldn't have the lenses interact, and they don't really work with the disk. The disk can't get very close to it. But what you really want is a system that will somehow bend the light all the way around the object kind of continuously, speaking qualitatively. And I found a really neat solution when I converted to an open source platform this year called Blender 3D. And the open source community had found a cool way of doing this with just nested spherical lenses. It's actually elegant and simple. And with a relatively simple 3D setup with like kind of a Russian doll's nest of spheres and a relatively simple descriptor of how the refraction changes as a function of radius, you can get effects that actually work pretty well and can be animated. You can see the distortions and doesn't require a supercomputer cluster to create. So just this year, I've had several opportunities to use this new technique to, I hope, reasonably good effect. And I'll defer to Kip on this, but I'm feeling that we've gotten to a point where even a short Blender render can now at least qualitatively get us in the same ballpark as a full general relativistic ray trace black hole. So Kip can comment on this more later, but this is an important point to get to because at the very least, I can say never again, at least in my own work. So how am I doing on time, by the way? Okay. Well, let me jump to like a final case study, and that is exoplanets, another thing that's just incredibly exciting to the public and gets a lot of attention. This is an absolutely astounding piece of data. It is exciting, but you might not tell. Well, I can add a little more context to it. It's something that you've all seen if you were at the planetarium yesterday. This is the star TRAPPIST-1, a very small M-dwarf star, about 40 light years away, and the data set was jaw-dropping to me the first moment I saw it, but not to a general audience. It requires a lot of interpretation to understand the significance, that you're actually looking at a system of 5 or 7 Earth-sized planets around an M-dwarf star. And if you want to get onto the cover of the New York Times, above the fold, mind you, above the fold, the artwork is going to be the thing that tells that story, that turns these abstract ideas of transits that block a little bit of the light of the sun into the idea of worlds. Now, when we do this, I was asked earlier, do I ever do traditional media? And I say yeah. I will say everything I do is digital, but I'm not above throwing a bunch of marbles on the floor and trying to rearrange them to get a composition that I feel is going to work for a kind of creative way to lay out the TRAPPIST-1 system. These are my bullet points that went into this, correct scaling of the planets, the sort of square root scaling of the radii to give a sense of the scale, but reasonably correct. Trying to represent the Hubble zone a little more excitingly than just putting the green swath that we typically do, of showing ice transition to steam with a region in the middle where it exists as liquid form, ways of communicating this. And pieces like this can then help tell the science story on the cover of Nature. It was my first Nature cover. I was very happy with that. But of course, there are other ways of getting at this result too. A little bit of my brushes, the way my brushes work on 3D graphics software and procedural trees to create fractal noise. But these are all hypotheses, and they change over time. And it wasn't only a year where we changed the look of it, because with new science came new ideas, new possibilities for what these worlds are. And these are never going to be the final statement. When James Webb Space Telescope observes these atmospheres, they'll probably completely change perceptions. But the art becomes a visual record of the evolution of the science. And there are, of course, coming up, we're going to find more about the JPL travel poster series. Joey Harris did this remarkable job using the same process that I use for the other graphics. We're on many of the same calls, talking about the science, finding ways to create and excite people, create that sense of wonder. I'll just flip through the end. Like, there are times like 55 Cancre E is the world I have illustrated the most times, and every time there's a different science result emphasizing something different about the planet, and it goes on, and eventually kind of ended up where it started, more or less. But again, that's fine, because this is, again, that visual expression of how science is constantly evolving and converging on, ultimately, a truth. So there are other ways to get that idea across too. The excitement of a lava world. These are wonderful ways to create incredible engagement as well. And so the JPL team will get into that later. So I think that covers more or less everything I want to talk about. Thank you for your attention, and I'll just tap through a few more exoplanets.